Okay, so if you've done some of the trigonometry, you realize that this is an angle. We use theta to describe angles, the same way we use x for, distant or regular numbers, things that may not be angles. Theta, if you see a theta in an equation, you can be assured that it's probably an angle. It's just a Greek letter, no big deal. So in the previous video, I said these are all locked together. And that is basically true, except in situations where you want the angle, there is a way to just get theta by itself. And here's how that's going to work. So in this case, we have the sine of theta by itself already. We do something called, I know this is going to come as a shock, we do something called the inverse sine. Let's be clear. This sometimes means flip something upside down, make it reciprocal. It's not what it means in this case. It is the opposite of taking the sine. It is just the same way square rooting is the opposite of squaring, or subtraction is the opposite of addition. It is the opposite operation. So what I never write this step, but we'll do it here. So I write inverse sine of the sine of theta equals, but remember I have to do it to both sides, like so. So I take the inverse sine of both sides. To be honest with you, I would never write that step, because what happens is this. Over here on the left, I end up with just theta. So I wouldn't normally write this like I was saying. Sorry, I had to pause, a little choppy on the video there. Because what we're going to end up here with on this side over here is just theta. Because the inverse sine and the sine cancel each other out. Over here I have the inverse sine of A over C. And that's as far as this one goes. I'm going to show you this real quick, though, just to help you out. My son's online on Skype. Isn't that nice? Maybe I'll Skype him later. Okay, so how do I get rid of that? I don't know. So let me just give you an example of this. So if you had the sine of theta is equal to 1/2, then, and I wanted to know the angle that did that, I'd take the inverse sine, so I have theta is equal to the inverse sine of 1/2. And then, on my fancy schmancy calculator, I could put in a half, right, 0.5, and then I could do inverse sine. No, I don't think the inverse worked. Hold on. Well, unless it's in radians. Hold on. Where's my clear? Let me try that again. Point might be in radians. No, it's in degrees, so 0.5. I just didn't hit it right. Inverse, there it is. See how the little inverse sine symbol shows up there? Now I hit it. There, 30 degrees. And that tells me that the angle that produces that sine is 30 degrees. So that's an example of when we'd use it. We don't normally have a situation where we have to leave an equation with an inverse sine in it. It's usually the last step in actually solving a problem, like this one. So let's see if we can try it again. So same deal, except now it's the tangent. Well, you'll notice on the calculator, when I hit that inverse button, there's inverse tangent, there's inverse cosine, there's inverse sine. All the three big trig functions all have their inverses. So in this case, we would simply take the inverse tangent of both sides. So theta would end up being the inverse tangent of A over B, whatever that is. All I did was take the inverse tangent of both sides. And I would have to squeeze that in over here, so that doesn't really work out. We'll do it like this. So the long version would be this, but really we just end up with that. We're good to go. So to find an angle when it's trapped by a trig function, you're going to use the inverse of that trig function. That's the major idea from this video. I don't think there's another one. Let's see. Now, you know what? We'll come back to that. We'll do that in a different video.